Alright, so now let's see some machine code and we'll see how our 8085 executes it. And I believe the easiest way to learn anything new is to look at some examples. So let's say someone gave you this 8085 microprocessor and said, look, I need you to figure out what this thing is doing. Is it gonna fire a nuclear missile or something? I mean, we don't know, right? What it can do right now. So let's try to figure this out. So what do we know? What do we have? So we know that 8085 microprocessor has an 8-bit accumulator and 6 other registers. So let's draw them. Next, we also know that it has a 16-bit stack pointer and a 16-bit program counter. So let's draw those as well. And it has a 16-bit instruction register. And we'll assume that initially all of these are filled with zeros. So over here it looks like they have given us few instructions of the processor along with the number of bytes it has and its corresponding opcode. And over here they have given us the execution cycle of 8085 microprocessor. It says instruction the address given by PC is loaded into the IR. PC is incremented by 1, 2, 3. So these look like steps the processor is going to follow when it is executing the program. And what's over here? This looks like sequence of code. So this looks like the program they want us to figure out. So the first thing we'll do is let's name the memory locations. We know that 8085 has 64 kilobytes of memory. So we'll start naming the locations from 0, 1. This will be location 2 and all the way. This will be 7. This is 8. This will be 0F. Note 16 in decimal is 0F in hex, and this will be 10. This will go all the way up to FF hex. Alright, so let's walk through this execution cycle. The first step is instruction at the address given by PC is loaded into IR. So what is the address at PC? PC has initially 0. So let's see what is at location 0. At location 0 we have DB. So what does this correspond to? DB corresponds to the opcode over here. And what do we know about this instruction? This is a 2-byte instruction. So the processor will take 2 bytes at a time. And it will be in the form of the opcode, which is the DB, followed by the port number, which is 00 in this case. So in this step, the processor will load these entire 2 bytes, which is DB00 into the IR. Next, the program counter is incremented by 1, 2 or 3 based on the length of this instruction. So because this is a 2-byte instruction, the program counter will be incremented by 2. So next the processor will decode the instruction. After that it says if this is an indirect addressing or a memory operation, load the data into the register. So we are loading the data from the port. So this is neither a memory operation nor an indirect addressing mode. So we'll just skip this one. Next we have to execute the decoded instruction. So this instruction DB00 will be executed. So do we know what is the value on the port? We don't. So let's make a logical assumption that it has, let's say it has 4 in it. So this 4 will be loaded onto the accumulator. Remember, we are not trying to come up with a definite answer. All we are trying to do is trying to figure out what this program is doing. And then it says repeat until you get 76. So we didn't get 76, so we'll do the same thing again. So let's repeat this. What's the address at PC? Now PC is pointing to 2. So what is the instruction at location 2? It is 47. And let's look what 47 does. 47 is a 1-byte instruction which moves the content of accumulator to the register B. So now our IR will have 47. Last time we had a 2-byte instruction. So we loaded 2 bytes at a time. This time this is only a 1-byte instruction. So we'll load only 47. Next, the program counter is incremented by 1, 2 or 3 based on the length of the instruction. So this time we had a 1-byte instruction, so we'll increment it by 1. Then the processor will decode it. Again, this is not an indirect or a memory operation, so we'll skip that. And then it says execute the decoded instruction. So this 4 will now move to B. We didn't have a 76, so we'll repeat it again. So now we are pointing to location 3 over here. So again we have a DB. which is load the data from the port to accumulator. But this time instead of 0 0 we have 0 1. So it seems like they are asking us to load the data from port 1 into the accumulator now. So again this time IR will have 2 bytes loaded. So we'll have DB01. Then the program counter will be incremented by 2 this time again. And again we don't know what's at the port 1. So let's assume it has 03 in it. Then we execute the instruction. So accumulator will have 3 now. And we don't have 76 yet. So we repeat the cycle. So now we have 80. What's 80? 80 is add B. That is, it will add whatever is there in A and B and store it again in A. So what's this gonna do is, this will add 3 plus 4, which will be 7, and again it will store it in A. So 7 will be stored in A. So 80 will come over here. We'll increment PC by, this is a 1 byte, so we'll increment it by 1. Then we'll add 3 plus 4 and store it again in A. Okay. So what's next? PC is pointing to 6. At location 6 we have D3. So what's D3? D3 is out. Store the value of A at port. So it's, and again it's a 2 byte instruction, so we'll load 2 bytes at a time. So D302 will go into the IR. PC will be incremented by 2 again, and the execution will be to store the value at accumulator to the port. The port is number 2. So at port 2 we want to store the value at the accumulator. So in accumulator we have 7. So at port 2 we'll get 7. And then finally we have 76. So it looks like this is the last instruction which is gonna come to our IR, because as soon as it comes over here, it halts. So what did we learn about this program? We learned that this program will add whatever is present at port 0 and add it to port 1 and give it as output on port 2.